Welcome, everyone. Thank you all for joining us today. In this live stream event, archaeologist and science writer Rebecca Wragg Sykes joins particle physicist and broadcaster Brian Cox. Rebecca frequently writes for the Scientific American and The Guardian. She's also the co-founder of the influential Trailblazers Project, which highlights women archaeologists, paleontologists, and geologists through innovative outreach and collaboration. Brian is professor of particle physics at the University of Manchester and the Royal Society Professor for Public Engagement in Science. He's also currently a member of the ATLAS collaboration at the Large Hadron Collider, CERN. In this conversation, Rebecca will reveal the Neanderthals as curious, clever connoisseurs of their world, technologically inventive and ecologically adaptable, revealing a deeper, more nuanced story where humanity itself is our ancient shared inheritance. It is my pleasure to welcome Rebecca and Brian.
Thank you, and thanks for everyone for joining this conversation. I should just say that I jumped at the invitation to do this, to be involved, because I just loved Rebecca's book. If you haven't got it, Kindred, you should. Maybe you've all bought it, which is why you're here. But if you haven't, I just think it's a wonderful book because of the way that it merges the real hard science, actually. And it's going to be one of my first questions: is how do we know so much about Neanderthals? But also this beautifully, almost romantic writing. You were saying, actually, Rebecca, that you were in the poetry club, a fan of poetry, and in the poetry club at school. You really see it in the writing. So, so I jumped at the chance. But my first question is really, I think, one of the hardest things to imagine for anyone is the timescale that we're talking about. When we talk about Neanderthals, could you give an outline of how long they were here on Earth and how, when they disappeared and well, we'll talk later about how and if they disappeared and to what extent, but the timescales that we're talking about.
Yeah, well, thanks so much, everyone, for being here. It's really, really great to talk about Neanderthals to so many people. The thing with the time, a lot of people know roughly when they disappear from the fossil record, when we stop seeing their bones in their archaeology, and that's around 40,000 years ago, which doesn't sort of seem so old. But in terms of the period of time that they were actually around, where we can see anatomically evidence for the Neanderthal body, and in terms of the culture, that goes back to around 350 to 400,000 years ago. So that sounds like a massive more, but in fact, if you look at the broader scale of human evolution and all the different hominins that we know about, it's pretty recent. So you have bipedal hominins, so creatures walking around on two legs 3-4 million years ago, and the earliest archaeology now is 3.3 million years ago in East Africa, and that's simple sort of bashing of stones. Really, it's not sophisticated, but that shows you sort of actually Neanderthals and ourselves are very recent in that broader scale. So we emerge around the same time, around 300,000, 350, sort of different populations in different parts of Africa begin to show features that start looking like us, Homo sapiens. So we're actually contemporaries. If you take it right back to the beginning of the Neanderthals and the beginning of us, it's pretty much the same time.
And can you just define that term, hominin? Because it's a term that, well, it spans quite a lot of
yeah, so hominin basically means the group of sort of creatures, so apes, fellow apes, we're apes as well, but that are in broad terms within the lineage that is that's going to lead eventually to us. But I mean, obviously you take it back 6 million years, then you've got lots of branches that start with our common ancestor, but they go their own way. But we actually have, more than 15 different species going back sort of 4 million years now. So what sort of seemed to be relatively sparse a few decades ago has really started to fill out. And we also see that there was diversity in Africa, but also we're beginning to pick out different species in other parts of Eurasia as well now. So that picture has become a lot more rich and diverse.
And just before we focus on Neanderthals, so in terms of species, how many different contemporary species would there have been? I mean, we just say, well, there are humans now, and we sort of accept the fact that we're all the same species and that's it. But as you go back in time, how does that spread? How does the brand?
Yeah, as well, it's complicated because not everybody agrees on the naming and the definitions as well. So that's one issue. But you have us. So I'm sort of talking between about 50,000 and 300,000. You would have us, Neanderthals, Denisovans, which are what appear to be a more Eastern Eurasian species. You have this Homo naledi from South Africa, which looks anatomically very primitive, but actually is chronologically quite recent, 250,000, something like that. And then you have other things going on in East Asia as well. There's a newly identified one, Homo luzonensis, which we don't really know what's going on with that. And there's also those ones people probably have heard of, what sort of in the media they get called the hobbits. That's Homo floresiensis, which is a very tiny little creature, but it does appear to be around pretty late, I think to about 70,000 years ago. So overall, it's quite a busy world, more than we used to believe.
So really, yeah, if you go back 100,000 years or so, it's an unusual time, I suppose. The last 40,000 years, in a sense, have been unusual for us because there's only one species left, the Homo sapiens.
Yeah, this is the only time that it's been like that, I would think. And especially if you go back sort of into the millions of years, then the timescales are very large and the fossils we have are relatively few. So, you're picking those out over a million years, but even then we still see that there is great diversity in form as well. So I think it's always been a lot more of a busy bush, than just like a single tree leading towards us or anything like that. So,
and I feel like I'm jumping almost to the end of the conversation in a sense, but it really does. I think the thing that occurs to me is, did we as Homo sapiens have anything to do with this reduction of our great family tree down to one species, or is that too simplistic?
It's a terrible coincidence, a lot of people say, but I think in terms of whether we had anything to do with the Neanderthals, that's like a complicated question that people have had sort of in their minds for a long time. So there's a lot of possible threads to that answer. But in terms of whether we sort of impacted directly other hominins, that's more of an open question because many of those have only been discovered relatively recently. So we're not quite sure exactly at what point they disappeared. But what we do know is that the chronology for when the earlier Homo sapiens populations began to disperse out of Africa is a lot older as well than we used to believe. So the idea used to be that we left Africa and cleared the Neanderthals out straight away somewhere around 40,000 years ago, and that's really changed now. It's more, we've certainly got evidence that people are in the Near East area, well over 100,000, maybe as much as 180. There's been claims for a skull in Greece that could be over 200,000 years. That's not entirely certain because it's quite sort of fragmentary, but certainly what we do know is that Homo sapiens are in East Asia, in China, 80,000 plus, and in Australia before 65,000 years ago. So the span of time during which we would have met and interacted with other more archaic hominins that had already been in Eurasia for a long time, that has just got much bigger. So the potential for us having been responsible is looking a lot bigger than it perhaps once was. Yeah.
Well, one of the things that I really like about your book, and many things, but one of them is the way that you tell the story of how we can speak with any confidence at all about, in quite some detail, about the Neanderthals anatomically, but also the society and the way that they lived. But if we start, maybe it'd be good to give a brief outline of the history from the first discovery, and then just to outline the amount of physical evidence and data that we have?
Yeah, so Neanderthals are essentially, they're the hominins that we know best. They were the first hominins that we ever discovered. They were the representatives of other forms of being human, or being sort of types of human, of hominins. And with the Neanderthals, it's kind of weird because we found them, in terms of we recognized them, beginning in 1856 with a discovery in a German quarry. This was the Feldhofer Neanderthal find. But in fact, there had been previous discoveries, they just were not recognized as such. So the earliest discovery that we know of, that turned out to be a Neanderthal later, was in 1836 in Belgium. And that was actually accompanied by sort of extinct animal species, and it was sealed under a flowstone floor in a cave. But it was sort of not convincing. It was difficult because the skull was actually a child's skull, and Neanderthals, like our children, they don't grow into their fully adult form, so it wasn't quite so obvious. But the next one was 1848, so only a little bit afterwards, and that was a whole skull that was found in Gibraltar, in a quarry, to do with the military works on Gibraltar at the time. So that was British owned territory. And it was, we don't know who found that one, but it was brought to the scientific society that was run by the officers. And it was clearly interesting enough that somebody brought it, it was logged in the minutes as a skull, but they did not recognize quite how odd the skull really looked. And it was kept in the collections, but nobody really recognized that until after the German find in 1856. So the Gibraltar find was then noticed by a visiting doctor in 1863, who sort of shipped it over to Britain. So we sort of, there were like three of them suddenly. They all appeared once the German find was recognized for what it was. But it is an interesting question, what are people ready to sort of see? That there had been a relatively long history of interest and investigation in fossils and in animals and geology in the 18th century. And people were aware that there was a possibility for this, deep ancestry for humans, but it went against biblical sort of texts and chronologies and things. So that was a difficult question, but people were already imagining it. And there was a find in the 1830s in Europe of an ape, of a fossil ape. So I think that also was, sort of piquing people's interest in the notion. But it still took until the 1850s for the German skull to be found in the quarry, to be sent to a local naturalist, who then passed it on to anatomists. And at that point, it sort of had its own legs, and it took off across, the intellectual community in Europe. But in terms of where sort of our beginnings with them started, it's 160 years ago, essentially. They've been with us a long time. And that's why, in some ways, we know them the best, because they've had so much attention. But also, there is just actually a lot of fossil material. We have, in terms of numbers of fragments, we have thousands of them, and they represent probably somewhere between 100 and 200 individual Neanderthals. They're not all complete skeletons, obviously, but for a fossil sample, they're actually really good, and that's why we can say so much about their bodies. But it did take longer to sort of get to grips with their culture and the things that they made. And in fact, we didn't even know for many decades whether they actually made any tools. So they found the fossils, but there were no artifacts that were recognized with them, although there actually were, but they didn't recognize those either. So there was this weird situation of sites with stone tools with no fossils, and fossil sites with no stone tools, and that only shifted in the 1880s.
Yeah, I suppose, just going back to what you said, so the first discoveries will be pre-Darwin, I suppose. So when you
Yeah, just around then. I mean, that's kind of another weird thing. It's like this confluence of possibilities of technology in terms of mining, the Industrial Revolution, military activity as well. You know, that there was a demand for all this quarrying and the military being in Gibraltar, and the level of education of people as well, but also the notions of ancient creatures and of evolution were just sort of all coming together at the same time. It's a real sort of, you know, a time-space continuum. It was that moment when everything started to really, you know, blossom, and that's why they were not recognized earlier, I think.
So we've got, you said that about what, 200 individuals?
Rough, somewhere like that.
So we have a complete skeleton, as a complete skeleton from different individuals, or is it, what's the best example?
There are some sites where we have pretty complete skeletons. One of the earliest sites that was found actually in 1908 is a French site, La Chapelle-aux-Sons, and that was he's known as the old man because he is quite old and lost teeth and things, but his skeleton was pretty complete. We have other skeletons. There's a child from another French site, and in various other places there are relatively complete bodies, and sometimes you might have like the top or the bottom or something like that, and in other sites, yeah, you just have a tooth, but you can say a huge amount just from a few pieces, and especially, you know, we have massive technological advances now. We can, you know, if you have just one tooth, you can look at the morphology of the tooth, what shape it is. You can say, oh, it's a Neanderthal because it has distinctive features. But then you can look at the growth development of that tooth. You can sort of see, does it seem to differ from the rate of development of living people, especially during childhood. You can look at the tiny scratches on that tooth and assess what they ate to some extent, what other tasks they used their mouth for. You can look at the preserved dental calculus, so like, you know, the grot that you get on your teeth, tartar. You can look at what is in there. There's preserved microfossils of plants and even DNA. And of course, you can then like analyze the teeth themselves for DNA for the actual Neanderthals as well, and all protein analysis and things. So even if you only have one tiny bit, the amount you can do with it is, you know, just incredible now.
So we have a very good understanding biomechanically, let's say, because we have so many skeletons. As you said, you can do anything from almost from a tooth you could work out.
Yeah, the only caveat to that is that we don't have as many complete female skeletons, or at least that we can confidently identify as female, which is actually tricky in itself. Weirdly, all of the sort of high coverage genomes that we have are female, so they've balanced out. You know, there's more complete male skeletons, but we have more very high quality genetic information for females. So yeah, so that's kind of a strange balance.
So actually, while we're talking about that reconstruction, at the end of your book, there's a most beautiful passage where you write about if you could go and put your hand and put your hands and touch a Neanderthal today, you could go back in time or bring one forward and look into their eyes, and you'd recognize something that's distinctly human.
Yeah.
Could you just give us a sketch of what, if a Neanderthal were to be in the room in front of us all now, what differences would there be? What similarities would they be?
I think it would be striking how similar they are, but at the same time, you would definitely notice sort of they don't look quite as you would sort of expect. So they're going to be on average a bit shorter than most people. I mean, I'm quite short, I'm only 5'1", but average sort of male height would be 5'6", a bit more. So, you know, you don't really get 6 foot tall Neanderthals. But sort of
you wouldn't have had 6 foot tall humans maybe at that time.
Well, no, there are some quite tall early Homo sapiens slightly after the time of the Neanderthals, sort of 30,000, something like that. And even quite early, 1 million years ago, what we call Homo ergaster in Africa, there's a really great adolescent skeleton that's quite complete, and he was already pretty tall. So on average, they definitely were shorter, but what they lack in height, they made up for in sort of bulk. And I think overall you would be pretty impressed by seeing a Neanderthal. Their bones are thicker, and the proportions of the limbs are slightly different, but you probably wouldn't notice that. But in terms of sort of the muscularity and the impressiveness of their bodies, definitely they had they had more flaring out ribs, so they didn't have like a tucked in waist like we do. So they just would have looked, more barrel like in their chests. And the faces also, I mean, people focus on the brow ridge, which definitely that's an interesting sort of feature, but also even in newborn babies, because amazingly, we have skeletons of tiny infant Neanderthals, and the question of how they get into the archaeological record is an interesting one. But we can see even in like 2-week-old babies that the form of their face already looks different. The Neanderthals had sort of a pulled forward front of their face, because we have a lot of bone cells here that are absorbing sort of bone, so our faces are tucked under relative to our common ancestor. We've sort of gone a bit like pugs. And whereas Neanderthals, they have this more sort of bone growth sort of area, which means that they would have had large noses, and even the front of their faces pulled forward, but they don't have our chins. So you can definitely feel a little bony thing inside your own chin, and they wouldn't have had that. It would have gone back more. The shape of their head is also different. We have quite a sort of tall ballooning head. Theirs is more sort of, it goes back, and most of them had a little knobble at the back of their skull, which we call the occipital bun, which houses the visual system. And also they had just lots of small differences, because their faces pulled forward slightly more. They had a gap between the back of their jaw and the last tooth. So there's lots of tiny differences like that all over their body. But in terms of if you meet a Neanderthal and you see them, I think if you shake their hand, your hand's going to get quite crushed. They had a massively strong grip. Yeah.